On to number 21. Two friends are standing on opposite ends of a canoe that's at rest. The person in the front throws a very massive ball towards the back, and the person in the back catches it. After the ball is caught, the canoe is... it should be stopping moving, because if you've got your canoe here in the water, person here, holding the ball. When the ball is in the air being thrown to the left, so first of all, the initial momentum of everything is 0 before anything gets thrown. When the ball is in the air, that means the ball is moving left. That means the canoe and everybody in it was starting to move to the right with equal momentum. When the ball gets caught by the person on the left, now your final momentum has to also equal 0, meaning that everything comes to rest. 22. Standing on a skateboard at rest, a friend throws a very heavy ball toward you. You have two choices. You can either catch it or deflect it back to your friend with the same speed. Which choice would make you maximize your speed on the skateboard? So again, you're looking at which one would give you the biggest impulse. An impulse is m delta v. Your mass of the ball is the exact same. Your mass is the exact same in both cases. But the biggest change in biggest change in velocity is when the ball bounces away from you, changing directions. Right, going from v to negative v. That's a bigger change than v to stopped. So deflecting it would give you the biggest change in velocity. 23. A very elastic rubber ball is dropped. It lands with a speed of v. It's very elastic, so it bounces back up with a speed of v. Which of the following about the bounce are correct? There's only one answer that's correct. The ball's momentum was the same just before and after the bounce. And it says magnitude, so we don't have to worry about direction. Since it has the same velocity and the same mass, it has to have the same momentum. And magnitude is important because momentum has a direction. So if you just talk magnitude, then it doesn't matter up versus down. 24. A 1,200 kilogram car moving at 15.6 meters per second collides with a stationary car of 1,500 kilograms. They lock together. What's their combined velocity? So you got 1,200 going at 15.6, collides with 1,500 stationary. Their masses are going to couple together, so 1,200 plus 1,500 v. Solve for v, you get 6.9. And last question. 5 kilogram ball collides inelastically head-on with a 10 kilogram ball, which is a stationary. Which of the following statements is true? A is going to be true. The magnitude of the change of momentum of the 5 kilogram ball is going to be equal to the change of momentum of the 10. That just means the impulse during the collision is equal for both objects. And choice D, the change of velocity of the 5 kilogram ball is going to be greater than that of the 10. We see that in terms of the first answer. We say that the change of momentum for the two is going to be exactly the same. Well, what's change of momentum? It's m delta v. So the bigger the mass, the smaller the change in velocity is going to be. So the 10 kilogram ball has a smaller change in velocity than the 5. Again, we realized this was kind of a tricky quiz, and it's hard to take tests remotely, so we decided to take the quiz just out of 20 instead of 25. So it gave you a grace period of 5 questions. Not grace period, but you know what I mean. If you have any further questions, feel free to email me. Thanks.